Okay, welcome back everyone. So now that we've gone ahead and set up our custom tool crib, what we're going to do is we're going to go ahead and use that tool crib to generate the toolpaths to cut out this wrench. So we're going to go ahead and start this like we start all of our other models. We're going to go ahead and define the machine, mill inches, and we're going to go to tool crib and we're going to make sure we select that new tool index that we just built. And we're going to select OK. For our coordinate system, usually we do part bounding box vertex. We're going to go ahead and change that to stock because when we do this, we're going to be using stock that is slightly oversized. And we won't have the ability to zero off of the part bounding box vertex because that's going to be slightly below the surface of our part. And you can see that here. We're going to be adding about 25 thousandths to the top of this so that we can come through and face this off. So we're going to use stock bounding box vertex, but we're going to set it up in our traditional fashion. Our x-axis is going to go along the x leading edge. Our y-axis is going to go along our y leading edge, and just adjust the direction of those so that they are pointing in the proper direction. The arrow always points in the positive direction. So this looks good. Right, how we have it like that. We can go ahead and select OK. Next, we're going to go to our stock manager. Now, when we do this, we want to make sure that we set our coordinate system to the FCS. That's the origin that we just set. And we want to add 25 thousandths in our Z. If we don't, right, our stock size is going to be 0.6 tall. Now, you can't really buy stock that is 0.6 inches tall, but you can buy stock that is 0.625. It should come out to 5/8 if my math is correct. Hey, there we go. I still got it. All right, so you can buy stock that's 5/8 of an inch thick. So what we're going to do is we're going to add on 0.025 to round that up. What we're going to do is we're going to face this off afterwards, and this will give us that 0.6 overall thickness. So we can go ahead and select OK. We're going to go to mill setup, and just like we usually do, we're going to select the direction we want essentially the spindle to look down on, because this is how it's going to recognize which features it's able to cut. So we're going to select our top surface. We can select OK. Then we're going to go to extract machinable features. Calculates all the features that we have. Generate operations plan. It's going to use the tools from our tool crib to figure out how to cut this. Generate toolpath. And then let's go ahead and simulate this. And let's see how this looks. And you can see here, what it's doing is it's coming in with a 1/4 inch end mill to remove the bulk of this. Now, I don't like that. I don't like using a small end mill for sort of bulk material clearance. We're going to change this out to our 1/2 inch end mill when we go ahead and edit this code. But it's running through here. Afterwards, it's going to do a contour pass. And again, it switches to an even smaller end mill. I believe it swaps out to the 3/16 end mill. There's no need to do this, so we're going to go ahead and make that a 1/2 inch end mill as well. It's going to clean out this center pocket, and then it is going to clean out these corners, do a finish pass in here, then it's going to address these holes. And that looks pretty good. Now, there's a few issues with this. One, we still have some material on the top of this part. right? Because we have to add a facing operation. And the elephant in the room is it didn't cut out this big hole here. So we're going to have to add in an operation for that as well. So let's go ahead and start addressing these one by one, and then we'll add in those missing tool paths. So for this rough outside contour, we're going to edit that definition. And the first thing we're going to do is we're going to change our tool. We're going to change this to our 2 flute 1/2 inch end mill. So we bump up that tool thickness. For feeds and speeds, our spindle speed when we do the calculations out, and remember that is 4 times V, our surface speed is V, and for high-speed steel cutting in aluminum, that is a value of 300. So 4 times 300 divided by our cutter diameter, which is 0.5. And when we do that math, we're going to get a spindle speed of 2400. To calculate our feed rate, that is going to be our spindle speed times our feed per tooth. And our feed per tooth for these tools is 2 thousandths times the number of teeth on our cutter. Now our 1/2 inch end mills have 2 teeth. So our feed rate is going to be 2 times 2 thousandths times 2400. And that's going to give us a spindle speed, a feed rate of about 9.6. We're going to bump that up to 10. And our Z feed rate and lead-in feed rate are fine at the 25% and 50% values. For roughing, we're actually going to keep in the roughing pass, which is what we haven't been doing beforehand. We've been just using the roughing pass to cut down to size. But we're going to keep this in. We're going to go ahead and change our cut amounts to 50 thousandths. For our clearance planes, our rapid plane, we're going to change our rapid plane to 0.1 for the top of the stock. One thing we do want to make sure of is to turn this CNC cutter compensation off. We're going to set up an accompanying tool table on the mill, and the mill is going to handle that compensation for us. So we're going to go ahead and turn this off. If we leave it on, it's going to give us a warning when we actually go ahead and try to load this. It's going to yell at us. So make sure we have our CNC cutter compensation off. And then we can leave the rest of this alone. So that goes ahead, that puts in that 1/2 inch end mill. And that's going to be a little bit better suited to clearing out the bulk of that material. So let's go ahead and change our contour mill as well. We're essentially going to set it up with the same parameters. There's no need for cutting it down with a smaller end mill. And what this is going to do is it's going to reduce the number of tool changes we have to do. So we're going to change our cutter to a 1/2 inch end mill. Feeds and speeds are going to be exactly the same as they were in the last operation, 2400, and then a feed rate of 10 with 25 and 75% values for Z and lead-in. For contour, there's not a whole lot we have to do in here except adjust our cut amounts to 50 thousandths. And this is just because this is what our machine can handle. If we start pushing it more than this, we're really going to be stressing the machine, stressing the tools. Just all around not have a good time. So we're going to go ahead and set that to fairly conservative 50 thousandths. And C-plane, we're going to change our rapid to 0.1. And again, make sure our CNC compensation is turned off. And we can go ahead and select OK. So we've got these swapped out. Now for this rough mill in here, for the bulk of this material clearance, we can change this to a 1/2 inch end mill as well. There's no need to use the 3/16 in here. The 1/2 inch end mill will do that in one zip. So we're going to go ahead and change this rough mill operation. We're going to change our tool to the 1/2 inch 2 flute end mill. Feeds and speeds are going to be exactly the same as they were in the last 2 operations. We're going to come in and we're actually going to rough this out, or we're going to do a contour pass in this pocket here. So we're going to leave some allowance. And the reason why we have to do a contour pass in here is because our cutter won't actually fit, the 1/2 inch end mill won't actually fit into these tight radii. So we're going to use a smaller end mill to go in and clear those out. So we're going to leave some allowance, and we're going to adjust our cutting depth just like we have been. NC plane in traditional fashion, 0.1. And the reason why we want to keep this tight, we want to keep that tight, is so we don't run out of Z spindle extension. If we have this at 1 or 2 inches, that spindle is going to have to retract up 1 or 2 inches over the part. And some of the cutters we're dealing with are quite long, and we might not actually have that amount of travel. So we're going to keep that fairly tight for our rapid plane. Again, cutter compensation turned off. And you can see it turned that multi-pass into a pretty quick one and done in here. Now we do have to come in and clean up these corners. Because we're cutting this with the 1/2 inch end mill, and these are tighter radii, you can see we can't actually quite reach in there. So we're going to come in with this 3/16 inch end mill, this rough mill 3. The tool we're going to keep, we're going to use that 3/16 inch end mill. What we're going to do is adjust the speeds and feeds. Now when we calculate the spindle speed for this, this is going to be 4 times 300 divided by 0.1875. And what we notice here is that's a pretty high RPM. Now, our machines can't actually do that. We're limited to about 2,800 RPM max. So unfortunately, we cannot cut at the optimum RPM, but we're going to do the best we can. So we're going to set our spindle speed to 2,800. Our feed rate, when we calculate that out, 2,800 times 2 times 2,000s, it's going to give us a feed rate of about 11. I'm going to bump that back to a feed rate of 8. Just because we're dealing with a smaller cutter, we want to cut a little bit more conservatively with that than we would with something like a big honkin' 1/2 inch end mill. It's a pain when we snap a cutter, so we're going to do everything we can to avoid it. Z and lead and feed rates are fine at 25 and 50%. For roughing, again, we're going to leave in some meat in here because we're going to actually zip around this again with the same cutter in this contour mill. But for our cut amounts, we're going to set that to 50 thousandths. If we were removing substantially more material than we are, I would bump this down even smaller. I'd bump this down to about 25 thousandths. Right? If we didn't change this roughing mill operation here to a 1/2 inch end mill, we would want to bump that down. Since we're just cleaning up these corners, we're not doing a lot of heavy cutting, we can cut this at 50 thousandths. And for our rapid plane, we're going to adjust that to 0.1 as well. Again, cutter compensation turned off. So we're looking pretty good so far, trucking along. This contour mill, it's going to come in and clean that up. We're going to essentially use the same parameters that we did for the last one. Tool is staying the same, but our feeds and speeds are changing. Spindle speed is going to be that 2,800. Our feed rate is going to be 8. That looks pretty good. Contour, set our depth of cut to 50 thousandths. NC plane, 0.1, and CNC cutter compensation turned off. Now we come to the drilling operation. What it's going to do is it's going to drill through these holes with a 3/16 inch diameter drill. We actually don't have much we have to edit on this. Our tool we don't have to change. Our spindle speed, we can change this. It's going to be the same. It's going to be 2800 RPM. We're actually going to leave that spindle speed the same as our end mills. Drill hole parameter. So when this drills, it's not just going to take that drill bit and bury it down in one continuous pass. It's going to do an operation called pecking, and that's where it kind of just comes in and pecks it a little bit at a time. And that's to help clear out chips and to kind of help reduce heat. The peck amount, how deep it goes down each peck, is going to be 100 thousandths. We can change that. We can make that 50 thousandths. And for our NC plane, we're going to change this to 0.1. And we're going to select OK. Now let's just see how this all looks up until this point. That's looking pretty good. That was a little fast. Let's run through that one more time. It's coming in, cleaning up the outside perimeter with our 1/2 inch end mill. Cleaning up this inside pocket here. Drilling and counterboring. So what we have to do now is adjust this counterbore, and then we can go ahead and add in the facing operation and this milling operation. So this contour mill, it's going to come in and drill this counterbore. It's going to be the same operation as this 3/16 inch mills here. We're going to set it up just the same way. Feeds and speeds are going to be 2800. Feed rate of 8. Now, in this, it's going to not quite be doing a plunge. A plunge is where it takes just the 1/2 inch end mill and plunges it into that thick material. It's not quite doing a plunge, but it's almost doing a plunge. So what we're going to do is we're going to set our Z feed rate to come down very slowly. Especially with these small diameter end mills, you don't really want to be plunging at all, but if you do, you don't want to be plunging quickly. So that's coming in at just under an inch a minute, which is fine. It's not going in deep. So it's not going to add too much time to us, but it is going to potentially save us from snapping this end mill. For contour, we're going to go ahead, set this to our 50 thousandths. You know, unlike what we've been doing, we're cutting in aluminum for this piece. We're not going to cut in wax. So we do want to be a little bit more conservative in our cuts. So this all looks fine. Our NC plane, we're going to change to 0.1. And again, cutter compensation is turned off. Now, for reasons I don't fully understand, it feels the need to add this countersink operation. We don't actually need this countersink operation, so what we're going to do is we're going to delete this. Now let's see how this looks. All good up until here. And when we jump to the end, this all looks fine, right? It does exactly what we expect it to. So what we're going to do now is we're going to add in this boring operation here. Now to do this, we're going to go to Mill Part Setup 1, and We're going to add a 2.5 axis milling operation, and we're going to add a rough mill. We're going to do this with our 1/2 inch end mill. And for features, we have to create a feature here. We are going to select this perimeter. Our end condition is going to be up to face. And we're going to select this face here. So we're drilling to the bottom of this feature. And then we're going to select OK. So it recognizes this circular pocket with our 1/2 inch end mill. We're going to select OK. And that's going to add that roughing mill operation in here. So our tool, 1/2 inch end mill, speeds and feeds and speeds are going to be the same for all of the other 1/2 inch end mills. Now, because we are doing a plunge with this, we're doing a straight plunge with this 1/2 inch end mill, we're going to slow this Z feed right down. We're going to slow that down to 1. Plunges are pretty hard. We try to avoid them when we can. If we were doing a lot of these holes, we would probably pre-drill this, but because we're only doing one, we're gonna live on the wild side here and see what happens. For roughing, we can add in a clearance pass to this. We're gonna cut this right down to stock, right down to finish size. If this were something like a precision bore that we were pressing a bearing into, we might want to take a little bit more diligence in this. That's not the case in this case, so we're going to just do that in one and done. For first cut amount, we're going to set this to 25 thousandths. Again, we're going to be a little bit more conservative. Instead of that 50 thousandths, we're going to do 25. A straight plunge is pretty rough on the tool, on the equipment, so we're just going to take our time and let it bore this out. And C plane is still going to be that 0.1. Cutter compensation turned off. And then let's see if that, yep, that looks pretty good. So now when we simulate this, there we go. Now all we have left to do is to face this. So this is where we're going to add in a new 2.5 milling operation, and we're going to select face mill. 2.5 inch face mill, feature, create new feature, 2.5 axis. We're going to select this face here. Our end condition is going to be, let's see, up to stock, I think should be. If not, we'll fix this, but I think up to stock is the correct answer we need here. Maybe not. Let's see. Feature, create feature. This top face, end condition. We will do a blind of 30 thousandths up to face that off. That should work for us. No, still not. Don't make a liar out of me now, Solidworks. Oh, here we go. This is what I was missing. So we're going to select face feature. That's what I was missing. There we go. End condition should be up to stock now. There it is. That's what I was missing. Okay, so face feature, click OK. It's going to come in here with that face mill. Feeds and speeds for the face mill, I'm going to define by operations. So that's going to be 4 times 600, because our face mill has carbide inserts, divided by 2.5. So about 1,000 RPM. Our feed rate, we're going to set that to a feed rate of 5. And then a feed rate of 1 will be fine for our Z feed, right? The reason we're going so slow for the face mill, we're not cutting off a lot of material, but we want it to have a really good surface finish on the top there. So that's why we're going so slow with that one. For facing, we're going to do this all in one facing operation, so our step over is not really going to be important here. We're only cutting off 25 thousandths off the top, so our first cut amount and max cut amount are fine where they're at. NC plane, we're going to set to 0.1, and we can select OK. We can generate our toolpath, and we can simulate this toolpath now. Just like we've seen before, our 1/2 inch end mill, buzzing that out. It's going to zip around. Do our contour pass. Cutting those counterbores. And then just buzzing that all clean. And that looks perfect. Now, before we go ahead and finish this, what we want to do is just reorder these slightly, right? Because it's going to follow this tool change iteration. And what we don't want to do is go from our 1/2 inch to our 3/16 to a drill, back to our 3/16, back to our 1/2 inch. So we're going to go ahead and take this rough mill operation here and drag this up to be clustered with our other 1/2 inches. So that way it does all these operations in one go with that one tool. We don't have to change out tools. Next, we're going to take this drill operation and drag it up underneath those 1/2 inches. Come on. There we go. And then we're going to have our 3/16 combined, then our face mill. So this is going to limit the number of tool changes that we have to do. And we can simulate that just to see how that looks. This way we're not going back and forth with tools. It'll do it one and done. And we're done with that tool. Perfect. Now let's see what our total toolpath time is for this. Total toolpath time is gonna be about an hour plus 12 plus 2. So we're looking maybe about an hour and a half, 2 hours for this total cut time. Now, in looking at this contour, this outside contour, we can in fact speed this up. We can edit that definition, change our cutting depth, and we can make that 0.1. So 0.1 depth for this contour mill 1. It's going to be a little bit more aggressive, but we're not removing a ton of material. So that's just going to save us a few minutes on that. The rest of these I would probably leave as they are. Our drill looks fine. I would not adjust the 3/16 any. And our face mill, we don't have anything to adjust. So we saved ourselves about 6 minutes on this outside contour here. We can kind of push that a little bit, and this is just something you get with experience. Just sort of knowing how far you can push these tools. And, if this were a true production environment, we could probably push these a little bit further. But since we're just learning right now, this is an education environment, we're not trying to crank these out. We're going to leave this as is. So what we can do now is we can go ahead and post-process this, and we can save this wherever it's convenient for us. And we're going to go ahead and run this. And this will finish pretty quickly. We got to let that run all the way through. And now we can go ahead and send that code right to our mill. So if you guys have any questions on this, let me know. Hopefully this all works out for you. It should. And then this way we can just dive right in next week and start cutting these right on the mill. So follow along. If you guys have any questions, leave me a comment, send me an email. You guys know the deal. And I will see you guys in the next video where we talk about generating the soft jaws for this. So check back for that, and I will see you guys in the next video.